here to present another session of this learning session that we have today. Myself, Alex, and Arthur and Adam are going to be presenting the Proxy Pallet. So the agenda is very similar to the rest of the sessions we already had. First of all, we're going to see the main purpose of this pallet. Then we're going to see some of the high-level features that it has. We're going to go and see how it's used in Polkadot. Then we did a bit of research about the dependency that is using with another pallet. And to end up this first part of the presentation, Arthur is going to go through with a demo. So we are going to be able to see how it's used and how it's used. And then we're going to stop here for a Q&A. And after that, Adam is going to go through more technical, more in depth, looking into the code. And we are going to end with another Q&A session. So first of all, the main purpose of this pallet. The main purpose of this pallet is for us with an account, allow another account to act on behalf of us. So we can see that to understand it better in a high level, with a high level example, offsite blockchain and offsite poll. Imagine we have a house with a garden, and in this garden we have a dog, and we are going on holidays, but we want someone to be able to feed the dog. So we can give the keys to access that garden to someone else, let's say your brother or some friend. So he can access the garden, he can open the main door, access the garden, and feed the dog. That's the task we told them to do. But they are not gonna be able to go inside the house, and they are not gonna be able to control to go inside other parts or to control other things on the house. So just gonna be able to do the task that we are giving them permissions to do, feed the dog in that case. If we go more into how it's using Polkadot, into blockchain, it means it has like an extra layer of security. So if we imagine we have an account and we want to participate in all the Polkadot ecosystem, we have our account with all our funds, but we want to take part in the staking, we want to be able to take part in democracy, we want to be able to vote for proposals, etc., etc. So we can create different accounts, and we can create a proxy from the main account to all these different accounts. So each of one of these different accounts is going to have just one specific task. Do a staking, work with the voting that in governance. But our main account or a stash account is going to be secure. It's going to be more isolated. It also allows us to configure time delay. So we can imagine that as like there is like election vote in 1 year, and we are not going to be able to vote for that. So we can give someone permission to vote on that election on our behalf. So we proxy to that account, and they are going to be able to operate with acting as if they were us. Also, announce the action. That means we can announce what action is going to happen. So in that case, in that scenario, they can announce, okay, so for this 1 year election, we are going to vote for that. So that's announced there, and this is going to happen. And finally, the last purpose of this account, there is we can create a special kind of account that is called anonymous proxy. That's an account that is special because it has no private key, and it can only act via one of their configured proxies. Now we'll see some terminology to be able to understand all these concepts that are related to this pallet, to the proxy pallet. The first one is that we already seen, the proxy account is the account that might act on behalf of another person account with restricted or unrestricted access. That can be called as well delegate account. And then on the other hand, we have like the real or proxy account. That's the other part of the equation. It's the account that the proxy will make calls on behalf of. Then we have the proxy type. The proxy type is a value that defines the subset of calls that a delegate is allowed to make. That basically means the permission that they have with regards to our account. We're going to see in the next slide, we're going to see all the types that the Polkadot ecosystem, the Polkadot allows us to create, all the Polkadot proxy types. Then we have the concept of delay here. In the same example we mentioned before about the election that is going to happen in 1 year. So the delay concept here is this 1 year, but it's not measuring in years, it's measuring in the amounts of blocks that is going to happen until before this call, maybe this patch. We talk about the announcement. The announcement is the publication of the hash of a proxy call that is going to be made in the future. And then we have the concept of deposits here. So in order to create a proxy or to make an announcement, we have to put a deposit. That means we have to want some tokens. So some tokens from our free balance is going to go to a reserve balance and are going to be reserved to do that operation. And when we delete that or we cancel that proxy, we're going to have this money back. We have that deposit base that is for the base for the creation, and then we have the deposit factor that is we need for one of the proxy that we create. So the total formula is this: total deposit is total deposit base plus deposit factor multiplied for the number of proxies we are creating. So yeah, now we want to see the proxy type that we have in Polkadot. The first one is any type. That allows the proxy account that we set to make any kind of transaction on our behalf. That basically means that another account has full access to our account because we are allowing him to do all the transactions. As you can see, that's the less restricted and also can be the less secure too. We have one that is a bit more restrictive, that is non-transfer. So it's allowed another to do all transactions, except the balance transfer. So it's not going to be able to take money from our account and send that money to another account. Then we have governance that allows to make transactions related to government. That means democracy, council, treasury, proposal in the treasury, the election pallet, and all these governance transactions. Then we have staking. So we create a proxy related staking, going to be able to do all the staking operations. In staking, if you are familiar with staking, notice that there is already two kinds of accounts that you can create with staking. One is the stash account, and one is the controller account. Just like brief, because we are going to have another session talking about the staking pallet, but just briefly, usually with the controller account, you use that account to do all the day-to-day operations, like nominate, validator, and some of the day-to-day operations needed. And you have the stash account where you have your funds, and you only do operations like put more tokens with that account. That's kind of a proxy. You can see it, but the proxy type here is do not confuse with that. It's like an extra layer to that. So in that case, we can even isolate more the stash account. We can have the stash account and that proxy to our staking account that can do all the operations that usually the stash account does. So our stash account will be like much more isolated, so less used. And on the other hand, we can have that with a controller account too. So in that case, you can have like some kind of backup, some kind of emergency. So in some case, if there is something wrong with our controller account, we have a proxy to another account that can perform the same operations too. Another type we have is the identity judgment. In this case, in search of allowing register to make judgment of an account's identity, that's working with the identity palette. We have the cancel proxy type. It allows us to cancel something that has been announced. So imagine a proxy account that we set up to vote in that election that is going to be 1 year ago, already decide what it's going to be. So okay, I'm going to vote that. So with this type of cancel, we can just change our mind before it happens and cancel it. That's very useful, and it adds also more security to that kind of calls. Then we have actions to allow to the transaction to all these parachain action and grow laws. We have the time delay. That's exactly the example we've seen with that election that is going to happen in 1 year. And lastly, we have a special kind of proxy that is called anonymous proxy that is generating a new special kind of transaction that is going to be an address that has not a private key. And now we are going to see that more in depth because it's the more special of this type, and it's very, very interesting. First of all, before explaining this anonymous proxy, just wanna say that there has been a debate for a long time that about the name used here, anonymous proxy, because usually in blockchain, when we talk about something anonymous, the first thing that come to your mind is something like Monero, no? When you can do transaction in an anonymous way. And here, anonymous means a bit different thing. So it means that there is an account that has no control, has no private key attached to them. So kind of like breaking news here has been a pull request just a few days ago that was accepted into Substrate that it changed that name. So we changed the name anonymous proxy per pure proxy. We decide to keep the name anonymous into this presentation because it's still in all the wiki and maybe to don't make a confused term. But just for you to know that this anonymous proxy has been decided to be changed to be pure proxy. After all the explanation of the anonymous proxy, then you are going to understand maybe if you like it more the name or not, and I'm going to share you the link to the forum where this was debated. So going back to the explanation, we'll see here the first diagram. That's a diagram of the use case of a normal proxy type. So we have the stash account, and we assign a proxy with another account. Okay, we'll go later with the comment. So okay, so we assign a proxy to that account, and that means that this account is gonna be able to act on our behalf. So it's gonna be able to sign on behalf of us. With anonymous proxy, it's a bit different. So we have the stash account, and we create a new address. So we create a new anonymous proxy. This anonymous proxy has no private key attached. So that's gonna change roles. So now the stash account is gonna be the one that is gonna act as a proxy to this anonymous proxy. So it's gonna be the one that signs on behalf of the anonymous proxy. Maybe a bit better with that picture here, we can see that we have like the primary account, and we can call this extrinsic call anonymous to create. It's gonna change to pure, but to create a new account. So we create a new account, and then we switch roles. So the user primary is gonna be the proxy to this account. And why is this useful? So the first thing it is useful, we'll see in the diagram below, in the diagram at the bottom, is for extra security again, no? So we have this stash account, so we create the anonymous proxy, and then this stash account act like a proxy for this account. And from this stash account, we also can create a different kind of proxy type. So we can assign a proxy for staking, another one for governance, and then proxy is gonna act on behalf of the anonymous proxy. So in that scenario, we keep all the funds in the anonymous proxy because the anonymous proxy is not gonna be compromised directly because it has no private key. The only way it can be compromised is if the stash account is compromised. So if the stash account is compromised, then we from the anonymous proxy we still can change that interaction. That also means that if we just delete this, we have to be extremely cautious when we work with that kind of proxy, because if we just delete this relation between the stash account and the anonymous proxy, all the funds that are in the anonymous proxy are going to be lost forever because it has no private key. So the only relation is with the stash account. If we delete that account with both the funds, we're going to lose that fund. Another use case that is really interesting about this anonymous proxy is the permission management. Last Friday, we have seen explanation of what a multi-sig account was. Just here, imagine we have a multi-sig account. That means that we have four different accounts attached to that multi-sig: Alice, Bob, Charlie, and Dave. Forget for now the part of the anonymous proxy. If we want to delete Bob from here, because let's say this multi-sig account is of our company and Bob is just leaving the company. If we want to delete Bob from that relationship, that means that we are going to change the multi-sig account, because the multi-sig account depends cryptographically with the Alice account, the Bob account, the Charlie account, and the Dave account. Using an anonymous proxy here, we can fix that. So if we wanna now we can see with anonymous proxy that we have like Charlie account, Dave account, and the anonymous proxy that is proxy of Bob and Alice. If we wanna delete Bob here, it's not the multi-sig account is not gonna change. We just have to go to the anonymous proxy and check that relation that it has with the Bob account. That means that we also can add a lot of different new accounts here, just adding the relation in the proxy. We don't need to change the multi-chain. Okay, so that's it with Anonymous. Now, let's see how it's working, how it's been used in Polkadot. We're gonna see more in depth with Arthur. He's gonna show us the demo on how to create a proxy. But the only thing I want to show in that screenshot that is from Polkadot.js is the balance. The balance we have to deposit. So it's a bit more than 20 lots. That's because when the implementation in this pallet in Polkadot, it has been set that the deposit base that we told before is 20.008 dots. And for each proxy that we want, so the proxy deposit factor is going to be 0.033. So that's the formula that we have. If you want to play around in Kusama, it's a bit less the deposit that you have to put in order to create proxies. Another interesting thing here, that's with the user interface, that's the kind of type of proxy type that you can create. Any type, non-transfer, governance, staking, identity adjustment, cancel, and auction. And if we want to create this special proxy, like anonymous proxy, you just have to go and do it with the 3.6. So here we have like the anonymous extrinsic to do it. Finally, dependencies. We've been researching that, and there's not really dependencies apart from the trivial one like the balances, just for the reserve, for the deposit. So here we finish the first part. Now Arthur gonna have to go through the demo.
So yeah, the first demo is the more like user-friendly approach using Polkadot.js UI. So let's just create a proxy for Charlie. So we have this option right here in the Accounts tab. So add proxy. Here we can select who will then operate on Charlie's behalf. So let's select Dave. And here we have all those types, proxy types. So let's just select staking here, and we have the reserve balance amount here, and sign and submit. So now we have the add proxy in. So we have this little guy here, the prox overview. So we can also add more proxy or even delete or clear them all here. But let's keep it. And okay, so here on the events, we have proxy added, just as we expected it. And okay, so let's try to stake some funds. We go here and accounts, let's nominate. And now we're Charlie. And yeah, let's keep Dave as the controller. That's too much. 9 is okay. So selecting validator. And here is the new thing, because now we have this proxy account here, selector, but okay, we have only Dave here. And of course we can always just sign and submit as Charlie, but let's use Dave here. So use a prox for this call. So now we will sign and submit as Dave. Okay, so the staking operation is in, so we can see the proxy executed here. And the interesting thing is that Dave was the one that paid the transaction fee. So okay, and okay, so maybe the not that user-friendly approach would be using Dave proxy, and the real here is Charlie. And okay, so we have the staking again, but now it's bound extra. It's another 9 and zeros. So extrinsic got in, so now we have 18 here, but then Charlie decided to, I don't want that proxy anymore. So let's just clear them all. Okay, so Charlie now has no proxy, no reserve amount here anymore. And then if they've tried to submit the same extrinsic, we got a proxy error here. So not proxy. So that's the first demo. The second one is the more complex one, but yeah, I think we will have to use the developer extrinsics. So let's use Alice to create a pure. I'm using the substrate master here, so it's already using the pure naming, but it's the anonymous that Alex just mentioned. So let's stick with the any, and yeah, just 3 blocks delay. The index can be 0. Okay, so let's sign and submit, and yeah, that's in. So here we have some interesting things. We have this event pure created, and an account was indeed created. So let's get this address and put on my account address book here. And this is the fresh proxy account created. Let's just put some fonts here. 9 again. So okay, now we have 9. So next thing is like Alice then really wants to send some extrinsics, controlling the brand new proxy account. So the first thing is to announce that. So we again need to use the real. The real now will be this new account. So I got it here, and we have the call hash. So you have to get it here. So let's do the famous one, like a balance transfer, and the balance transfer destination will be Alice, and just let me move just 8. Now the interesting thing here that we want is this call hash here. So we got it, and we put it here into the announcement. Let's announce it. Okay, so it was announced, the call hash. So now anybody, not only Alice, can like proxy that announced call. So here we have the proxy announced, and the delegate is Alice. The real is again our pure here. And okay, so it was the balances transfer to Alice. We have to use exactly the same parameters here. And so let's move that transfers 8 units. Okay, so now we have only 1 here because indeed the balances were transferred from the proxy account to get the funds got back to Alice. And yeah, so now another operation would be like Alice decided to just kill that pure proxy. So the extrinsic is right here. So okay, kill pure. The spawner is Alice. It was any. Now we have to pay attention on this. There's 2 parameters here. The height is the block number and also the extrinsic index. So we need to get back here where the pure proxy was created, this guy. So let's inspect the block. Yeah, the block was the 60 and the extrinsic index was 0, 1, so 2 was in fact the create pure. So we have the 60 as a block number and the 2 as the index. So 60 and 2. And yeah, I have to, Alice has to announce it. So let's announce this new call. And yeah, so inspecting the change state here, just to, oops, proxy, we have like the Alice pure proxy here, and we now have also one announcement, and then we can just announce and proxy announce again. So we have the same parameters here, but here we have a different call. Here and 60 and 2, because those guys are used to, he created the proxy, the pure proxy account. So we need that. So let's submit. And it was in. So as you can see here, we have 2 balance unreserved, one for the announcement that was removed, and also another one for the pure proxy. So if we get back here, we will have no announcements, and oops, yeah, the same thing, and no proxies. And yeah, but the heads up here is that this funds is lost like forever. There's no way to reproduce, to recreate the same pure account that we created once. So nobody would ever be able to transfer or to use this account anymore. If you try to create a new pure proxy account using Alex, the Adam will show you, but we will use the current block number, so that's impossible to get the same hash again. So then, yeah, that's it from my end.
Thank you, Hector, to mention that. Yeah, you can check that in the product updates. And Philippe and Dominic, yeah, I see now, as you mean, like setting a staking proxy to the controller and reading now the comments in the chat. I'm also sharing, as I mentioned in my explanation, I'm also sharing the forum link when this discussion about changing the name from anonymous to pure was taking place.
So that's the pallet code. What we're gonna do is, because the pallet is not very long, we're gonna just walk over most methods. Some I will discuss very briefly. Some I will dive a little bit deeper into the details, but not too much to, fit in time to go through everything. So first thing we have is a couple of structs, type definitions. And first thing is proxy definition, which is basically an instance of delegation. So that means, well, the word proxy is actually used in at least 3 meanings here in this palette. So first, proxy means delegate account, so an account which can act on behalf of another one, but it can be also used as an instance of these rights, and it can also be used as a verb to express the act of making a proxy call. So just keep this in mind if something's confusing. So yeah, this is an instance of a proxy relationship. Then we have the delegate account, the proxy type, and the delay. The delegator account or the owner account is not specified in this struct because these definitions are kept in a map where the delegator is the key. So it would be redundant to store it here. Then we have the announcement struct. It represents an instance of announcing a proxy call which is to be made in the future. Here we have real. This is the delegator account. But on the other hand, the delegate or proxy account is missing. Here, for the very same reason that I discussed with the previous struct. Then we have the call hash, which is what Arthur was copying during his demo, like when making the announcement. He clicked to make a call and then copied the hash, pasted it into this function. And there is height, which is a block number at which the announcement was made. Yeah, this is important because basically after making the announcement, there is some number of blocks of delay to veto or cancel the call which was announced. So we need to keep track of when exactly the announcement was made. Now let's go to the Pallet config event. Pretty standard thing. I don't feel like it needs to be explained a lot. We have the runtime call, which is pretty important here because it's the calls that are proxied. So the call must be a valid extrinsic parameter and a dispatchable, and it also actually needs to be the same as runtime call for runtime that is using this pallet. So that would be it. Then we have the currency. We need the currency to be reservable to make deposits for both authorizing proxies and making announcements. Then we have the proxy type. This is another important one. So as you can see here, it's type parameter. So the list of proxy types is not actually hard-coded anywhere in this palette. It's fully configurable on the runtime level. And the list that Alex was showing in the first part of the presentation, that was a list of proxy types that are used in Polkadot. But any other chain using Proxy Pallet could have their own list. So basically, the crucial trait here is the instance filter. What an instance filter is a type that is capable of filtering some objects of another type. And here we have the type that is going to be filtered. So these are runtime calls. So proxy type basically is supposed to be a type which has a capability to filter runtime calls. So one type could allow these calls, and the other type could allow those calls. I hope that's clear enough. Then we have a couple of constants. So first there is proxy deposit base and proxy deposit factor. So these are used for computing the formula for how much money is to be deposited for creating a proxy, authorizing the proxy. The bigger the proxy type, the higher the fee. We have maximum amount of proxies allowed for a single account. We have weight information for extrinsics. We have maximum amount of announcements that are allowed at some point in time. We have the hash algorithm used for hashing the proxy calls. Then we have another couple of constants for the deposit, the announcement deposit. So these two are related to the deposits made for announcing the call. Works exactly like the proxy deposit. And now let's get to the calls, so extrinsics. first call here is called proxy. Now it's very confusing because like first time I saw this, I thought this is going to be for adding proxies, but no, proxy means make a proxy call. So yeah, about what I said about the peculiar name here and the multitude of meanings of the word proxy. So there is not much code here because it's all made in a private function. So let's jump there and see what happens, right? Yeah, so we get the origin. That's I think pretty obvious. Like what happens here? It's our origin for the real account, and then what we do later is we filter the call based on the proxy type. There is special handling for the calls from this pallet itself. So there is here some logic which, for example, prevents making a proxy call that would escalate the proxy permissions in order to avoid, unwanted privilege escalation. We cannot do add proxy, remove proxy, or remove all proxies, or kill pure proxies unless there is a full permission type. And yeah, all these statements are for checking proxy calls to the proxy pallet itself. And the last line is actually applying the filter, which is encoded in the proxy type. So this is actually like applying the filter that the runtime developer has implemented. And yeah, if the filtering is like positive, so the permissions are appropriate, then we dispatch the call with the assigned origin made for the real account, so for the delegator account. So this is basically how the proxy calls are made. Now let's go back to the extrinsics and check out the next one. This is add proxy. So yeah, this time it's obvious that it means registering a new delegate for a given for the sign-out account. And again, here the logic is in a function called add proxy delegate. So you can see here we have a different terminology like delegator and delegatee. I'm not sure if that's even a word. First of all, we check if there is no self proxy, because apparently we don't want this because it doesn't really give any functionality and probably could mess up some stuff here. Then we create a proxy definition, right? Then a funny not funny, maybe an interesting implementation detail is that we're doing a binary search. So the vector of delegates for a given delegator is sorted, and therefore we could do a small optimization here and do a binary search to find that definition. So if it's found, then we raise an error because we're just about to add it, right? So that would be a problem if we added a duplicate. But if it's not found, then we try to insert it, obviously also raising an error if it doesn't fit in the bounded vector. Then we just adjust the deposit to be, in accordance with the deposit formula. So we add, value for the new proxy, and then last but not least, deposit event. So we are emitting an event stating that the proxy was added. So that would be how proxies are added. Then we have remove proxy, which is the opposite of add proxy. I will not go deeper into the implementation because it's basically the same, just the opposite. Like really nothing interesting. Binary search is used as well, and the deposit is also adjusted, and so on. Then we have remove proxies, which unregisters all proxies for the sender. So like totally purging the list for the origin account. Then we have the famous create pure, which up until very recently was called create anonymous. So this creates a special kind of proxy that Arthur and Alex have already talked about a bit. Yeah, so what pure proxy is actually a proxy of an account that is freshly created and nobody has other means of controlling it. So the only way of accessing that account would be throughout that proxy, and after all proxies are removed, this account would be inaccessible unless somebody makes a very lucky guess and discovers the private key. Now, what happens here is, yeah, sure, we check the origin. Then we create this pure account. So let's dive a little bit deeper into this for a moment. What we have here is we check the block height. We check the extrinsic index. We also add the who, so the delegator address and the proxy type, and the disambiguation index. More about this in a second. And we use this as an entropy, hash it, and then decode as an account address. And the index is yeah, as the documentation says, it is used in case when somebody wants to put a bunch of create pure calls in a single block, in a single transaction, to not yield the same address. Because if it were not for this index, all the other parameters here, so who, height, and this and this, they would be the same. So calling it twice in a single block would result in having same address generated in two calls, and that's not what we want. We want every call to create pure to produce a fresh address. So that's how the address is created. And then, yeah, we just make sure that there are no proxies for this address, just in case. I mean, in case somebody provided the same index twice, for example. Yeah, this is an external argument. So we need to check, because if somebody calls it wrong, like calls twice in a single transaction with the same index, we need to check if they didn't do that. Then we create the proxy definition, a new bounded vector with just this single proxy definition. We compute the deposit, we insert, and that's it. Now let's go to kill pure. So yeah, we check again who is calling, who is that spawner. So the account that originally created the account. Then the height, the extrinsic index, so all the parameters that were used for creating the pure account. then we compute this, and we check that the caller address matches, and then we just remove that pure proxy from our storage, and we unreserve the funds. Then announce. So announce takes real parameter, which is the account in the name of which the call is to be made, the call hash, which needs to be computed first. Then we check if the origin, the account calling this extrinsic, actually has an appropriate permission. So we would find a proxy where the delegate is who, so the caller. Then we create an announcement struct, and then we try to add this to the pending announcements, raising error if there are too many. Keep in mind there was some constant limiting the number of active announcements. Then we use an internal function to update the deposit. I will not dive into this because it basically does the same thing that we already saw in case of adding and removing proxies. And yeah, that's it. Then it's announced. Then we have a remove announcement. So the person who is the delegator can remove any announcements made by their proxies, by their delegates, thus vetoing or preventing the call from happening. This is basically like the role of announcements, to give the person who is the main, the owner of the account, to veto any decision made by their proxies. Yeah, so it's not really interesting. It just finds, you know, an announcement where the call hash matches the parameter value and the real. So the delegate account is the caller, and that's it. Then there is reject announcement. Oh, I'm sorry. I think I made a mistake. Remove announcement is for removing an announcement after it's no longer needed. Like, for example, if the call was announced, then it was made, like a proxy call was done, then the announcement needs to be removed to get the deposit back. And here, reject is what I have previously said. So reject is for, well, rejecting, right, an announcement from a proxy account. And then there is proxy announced. So proxy announced is the same as proxy. So make a proxy call, but this one is for calls that were previously announced. So yeah, we need to find a proxy. We need to compute the hash of the call to be made. We need to get the block number. Then we need to check if the call hash and the account matches, and then like if there is an appropriate announcement. And we also need to check if this announcement was enough blocks behind. So if there's configured delay has already passed, like when you use a delay of 30 blocks, right? We need to make sure that 30 blocks were mined, were finalized since the announcement. Otherwise, it's not possible to make the proxy call, because the account owner didn't have enough time to reject the announcement. And if everything's fine, then we do proxy. And here come events, errors, so storage. Nothing interesting, I believe. I think we have covered most of the code. All right. Thanks for listening.
Cool.
And goodbye.